positive 2 and 4. So we have x equals negative 4. You basically want to get that to like re equal 0 and add 4 to both sides. So that's our first factor. Then we do it again for the negative 2. So we get x plus 2. That's our second factor. And we're here for the positive 2. That's our third factor. And then for this 4, subtract 4, we get x minus 4. So these are our 4 factors. For the negative 4, negative 2, and positive 2, the graph is passing through. Okay, there's no weird behavior. It just goes through, does its thing, moves on. All right, so that means each of those 3 has multiplicity of 1. The x equals 4, however, this is what I call a bounce. It hits the 4 and then comes back up. So it doesn't go through the x-intercept, it hits it and then goes back. So it doesn't change signs there. So that means at the very least, it has a multiplicity of a 2. Okay, now all of this, p of x equals, and then we have something called an a. An a is what determines your end behavior. All right, so how do we get that a? That's where that's where the non-x-intercept points come in. And most of the time it's going to be your y-intercept. In this case it is because of that 1 right there. Or negative 1, excuse me. So that is a 0 and a negative 1. So it gives me that x, gives me that y. We can take that and plug it in. And solve for a. So that is 4 times 2 times negative 2 times 16. All right, so that's 4 times 4 that's another 16. So that is 256, I think. Let's find out. $256, I was wrong. Okay, and then you're gonna divide by the negative 256. So it's gonna make it positive 1 over 256. So your final equation, p of x equals 1 over 256 times x plus 4 times x plus 2 times x minus 2, x minus 4 squared. All right, any questions on that? I was just wanting to finish that up from Tuesday's disaster of a car class. Awesome. All right, you need 3.5. A lot of 3.5 comes from the transformation. So this is what I call the parent graph of a rational function. Okay, this number, this variable down here, that h, that's your horizontal shift. This is what changes your vertical asymptote. The k is your vertical shift. So this is what changes your horizontal asymptote because you're moving it up and down. Okay, if that A is negative, so this A right here, if it's negative, the function is reflected. So it's flipped over the x-axis. Not super important on a rational function, but if that A is greater than 1, not including the negative sign, this is a vertical stretch. If it was less than 1, it'd be a vertical compression. Not super vital to this particular stuff. This assignment focuses primarily on your vertical asymptotes, horizontal asymptotes, and x-intercepts. So in this form, this is from your assignment from 3.5. We want to find the vertical asymptote first. Okay, that comes from this guy. Okay, I want you to think to yourself opposite h, same k. So I see an x minus 4. So I want to think opposite here and think that's really a positive 4. That positive 4 represents your vertical asymptote. Okay, so I'm going to go over here to my vertical asymptote for x equals 4 and just draw a vertical line. This is terrible. All right, now, same k, this 3 out here, that's your k value. You keep it exactly as it is. That's your horizontal asymptote. So you're going to say y equals 3. That's your horizontal asymptote. All right, so the way that it looks on your assignment, let's see if I can pull it up. Actually, I don't think I can share my screen in 2 places. The way it looks on your assignment, they'll ask you, like the way that you have it graph is you graph the vertical and horizontal asymptote, and then it says like pick another point. I don't think it does it with these types of problems. I'll show you on another one. Typically what you're going to look for is an x-intercept or a y-intercept. All right. The x-intercept is going to be really hard to find on this one, but the y-intercept will not be. Because you plug in, actually no, it will be hard on this one. So I think on this one, you just have to match the vertical and horizontal asymptotes. Actually, I think I will pull this up. Where do I stop sharing? Okay, let me pull it up on the screen. Yeah, okay, so like this one, you see how it says 1 over x minus 4 plus 3 to identify the vertical asymptote as x equals 4, so vertical on 4, and your horizontal asymptote at y equals 3. And this term, this number, that 1 right there is positive. All right, so you can see all but one graph kind of face the same way. This choice, the first choice, second choice, and third choice, all those have A's that are positive. This last choice has an A that's negative. They're flipped over. So I'm looking for where I have a vertical asymptote at positive 4. So that occurs on the first choice, the third choice, and the fourth choice. I also want to look where the horizontal asymptote is at 3. All right, so that's going to eliminate the third one. So it's between these two. And since A is positive, okay, I'm gonna keep it the way it is. The parent graph, that's what it looks like. Does that make sense on that one? So like you can see right here, determine a rational equation. So I can see the vertical asymptote at x equals 4. and I can see the horizontal at y equals 1, and it remains where it's supposed to. So I can do I do f of x? So y equals 1 over x, and you're gonna do opposite. That says positive 4, so we're gonna say minus 4. And then plus 1. Okay. I'm getting ready to do this problem on your homework help, so we'll talk about how to graph this here in a second. So I'm going to stop sharing here and go back to sharing on this. Okay. So you can see it's coming up, but I want to talk about the horizontal asymptote. All right. When you graph a rational function that's not in reciprocal form, okay, you factor and you cancel. So that is step 1. Factor and cancel. X-intercept is a numerator equal to 0. Okay, so it crosses the x-axis, set anything in the numerator equal to 0. Vertical asymptote, denominator equal to 0. Horizontal asymptotes. Okay, so I'm going to show you what it looks like and then give you a mnemonic device that helps. If the degree of the numerator is greater than the degree of the denominator, you do not have a horizontal asymptote. If the degree in the numerator is less, so that's the highest exponent in the numerator is smaller than it is in the denominator, then your horizontal asymptote is automatically y equals 0. And if the degrees are equal, so the same exponent on top and bottom, then you divide your coefficients. Okay, so it is a stupid mnemonic device, but oh my gosh, it works so well. And it is Bobo Botten eats DC. Okay, ridiculous sounding, but I swear it works. So Bobo means bigger on bottom. Zero. So if the degree is bigger on bottom, automatically y equals 0. Botten, bigger on top, none. Eats DC, exponents are the same. Divide coefficients. Okay, so Bobo Botten eats DC. All right, so draw a graph. Here's a rational function. The first thing I want to do is factor it and see if anything cancels. So your numerator has a GCF of 2. Your denominator has a GCF of -2. And it looks like the only thing that's going to cancel are your 2's. All right. So first step is to find your vertical asymptote. Okay, that's denominator equal to 0. So we're taking the denominator, setting it equal to 0. So we would divide by -1, which doesn't change anything. Add 2. There's your vertical asymptote. Oh my gosh, I cannot do that. Next thing I'm going to get is the horizontal asymptote. Okay, so I'm looking for the degree. Okay, and whether you use the original or the reduced, it doesn't matter which one you do. You're going to get the same result at the end. I'm going to use the original because it's easier to see the degrees. The degree of your numerator is degree 1. Okay, because it's got an understood exponent, and your denominator is also a degree 1, understood exponent. So this is in each DC. Exponents are the same, divide coefficients. So y equals 2 divided by -2. That means you have a horizontal asymptote at y equals -1. And then the next thing you're going to find is the x-intercept. And that is the numerator equal to 0. Okay, so you have an x-intercept at 6, 0. Okay. So now I'm going to stop sharing on this screen and we're going to go back to the other one. All right, so we had, all right, so what you can see right now, see right here where it says draw, and if I move that around, you see it's changing my vertical and horizontal asymptotes. So we had a vertical, I forgot what it was. X equals 2, so right here. Oh. Okay, clear all. So don't click anything until you're ready. So at x equals 2 and at y equals -1, and then it does not have a 6 on there. So, all right, so I'm gonna have to adapt. Let's see. Let's do a y-intercept. I'm sorry for going back and forth, but that's just the easiest way to do this. Since x-intercept didn't work because it's off my screen on Lumen, I'm going to find the y-intercept and see if that helps. And for the y-intercept, you plug in 0 for x. So we have 0 minus 6 over -0 minus 2. So that is a -6 over a +2. So that is a -3. All right. All right, so -2, -3, so we're down here. You see how I have my y-intercept there at -3? So click that, and you've got your graph. Any questions there? So again, don't select anything until you have your x and y, your vertical and horizontal asymptote right where it should be. So this one was at 2, -1. And then I either needed an x-intercept, but that was off my screen, or a y-intercept to get that second point. Okay? Okay. Now I'm not going to keep going back and forth on this one, so I'm just going to stick to my iPad now. Oh, that was it. Okay. I thought I had more than that. Okay. So on, am I lagging? I'm lagging. Like, what the heck? This is good internet. What the heck? All right, well, this is fun. All right, so 3x squared plus 5x minus 12. You need to factor it. So when you factor this, I don't care how you factor. Some of you guys learn X method, slide and divide. I don't honestly care how you factor, but I'm going to factor it how I know, and that's by grouping. So multiply that 3 by that negative 12. And you want to find factor pairs of negative 36 that add to be 5. So it's going to be negative 4 and positive 9. And what I'm going to do now is break up that 5 into a negative 4x and a positive 9x. Negative 4 plus 9 is still 5. This is still the same equation. I've just broken it up. You group the first two and the last two. GCF of the first group is x. And then GCF in the second group is 3. So I've got a 3x minus 4 and an x plus 3. But like I said, if you use the x method or slide and divide or guess and check, I have no preference as long as you get the factors, okay? I know this method, this is the method that's mathematically appropriate and it's not a trick, but at this point, sometimes we need a trick, okay? So the X method works really well for that. Slide and divide works really well for that. So if you're not sure what I'm talking about, go Google those if you're having issues with your factoring. I'm gonna do the same thing for the bottom. So we're gonna multiply 2 by 15, which is 30. And we want factor pairs of 30 that add to be negative 13. So it's gonna be negative 3 and negative 10. You're gonna break it up. And I know I'm running out of space because I don't know how to make spaces. That's fine. Group the first two and last two. GCF of the first group is an x. Second group is a minus 5. So I've got a 2x minus 3 and an x minus 5. All right, I'm going to shrink those and get these out of the way. Face out of the way. Okay. So I've got a 3x minus 4 and an x plus 3 and 2x minus 3 and an x minus 5. Okay, I'm actually going to go ahead and have you find all the parts on this one. Okay, it's only asking for vertical and horizontal, but we're going to do all of it. Vertical asymptotes is denominator equal to 0. So 2x minus 3 and x minus 5. Okay, so for 2x minus 3, it's going to be positive 3/2. Add 3, divide by 2. For x minus 5, you would add the 5. So we get x equals 3/2 and 5. For horizontal asymptotes, that's based off degree. Remember, bubble bottom ECC. Bigger on bottom 0, so we're looking for the degrees. The degrees are 2. It's not bigger on bottom, it's not bigger on top. This is an ECC. So we're going to take the leading coefficients, 3 and 2, and divide them. So horizontal asymptote is at y equals 3/2. All right, now it doesn't ask for it, but I'm going to go ahead and have you find the x-intercepts. And that's numerator equal to 0. Okay, so for 3x minus 4, that would be x equals 4/3. For x plus 3, that'd be x equals -3. So as ordered pairs, 4/3, 0, -3, 0. What are the parts? Y-intercept would be next. And honestly, it would probably be easier to plug the 0 into the original function to find f of 0. And the reason I think it would be easier on this one is because 5 times 0 is 0. 3 times 0 squared is 0. 2 times 0 squared is 0. 13 times 0 is 0. So we have -12 over +15, which would be -4/5 would be your y-intercept. All right, that was a lot of information for that. But that is the primary focus on your 3.5 is graphing, is finding those key parts, finding x-intercepts, y-intercepts, and all that. Okay, so at this time, are there any questions? You can put it in the group chat if you want, or where am I going with this? Oh yeah. You guys are just seeing all the things right now. Okay. Are there any questions on the homework we have out right now? (3.4) question 8. Okay, let me find it. All right, you actually missed that. We did that one earlier. You came in at the end. Hey, we did that one here. All right, so we had to find the x-intercepts at -4, -2, 2, and 4. So x equals -4. If we make the factor for it, we have to add 4. So x plus 4 is your factor. Do the same thing for the -2, so x plus 2. Same thing for the +2, x minus 2. And the same thing for the 4, so x minus 4. At -4, -2, and +2, all they do is cross through. So each one of these has a multiplicity of 1. At x equals 4, it bounces. So it has multiplicity of 2. Okay. Next thing you need to do is solve for this a. All right, the a determines end behavior. And you get that from the y-intercept. This gives you an x and a y coordinate, 0, -1. Plug in the -1 for your p of x and the 0 for all of the x's. Solve for a. We get a equals +1 over 256. So that makes your final function 1 over 256 times all those multiples, all those factors. I would have to see what that looks like, so I'm not sure. Because I only see what I have on my teacher preview. I don't see what you guys do. Let's see if there's a way to do that. Okay, hold on. I don't know what vertical line you're talking about on that picture. Yours is literally the same thing. You have an x-intercept at -3, -1, +1, and 3. And your y-intercept is at -4. So you would do the exact same thing. So you have your x equals -3, so it'd be x plus 3. You have x equals -1, so it'd be x plus 1. You have x equals +1, so x minus 1. X equals 3, so it'd be x minus 3. So we have a, x plus 3, x plus 1, x minus 1, and x minus 3. On yours, your -3, -1, and 1 are all multiplicity of 1. So they get like understood exponents of 1. At your 3, it's a bounce, so it gets exponent 2. And then you have a y-intercept at -4. So that means 0, -4. So you're going to plug in -4 for p of x and 0 for all of the x's. Okay, let me finish with this question and then I'll get yours, Nancy, okay? And then let's see, 0 minus 3 squared. So I'm not going to finish solving that because there's a couple more examples. There's a couple more students wanting this, but you would work that out and then you would solve for a, and that would go in for your p of x. All right, so 3.6, number 7. Hold on, I'm trying to find it. Okay. Right back. Stare down, does it look like this for you? Yeah? Okay, perfect. All right, so what you're gonna do, okay, the first thing is that the inequality has to be a 0. Okay, so it has to have the polynomial, then on the right side it says 0. Then we're gonna factor that. So factors of -12 that add to be 1 are +4 and -3. Okay? Now, this greater than or equal to sign, this means we want positive solutions. And so what I'm going to do is I'm going to create a number line. I'm going to solve these factors. So this one I'm going to get x equals -4. And this one I'm going to get 3. I'm going to put them on my number line. And I basically have 3 zones to test to see if I get a positive solution. I have this one, the one in the middle, and the one at the end. Okay. So I'm going to choose a value that's less than -4. So like -5. So I'm going to plug in a -5 to this and see if I get a positive solution. I don't care about the number so much as the sign. Is it positive or negative? So negative, let's say I'm doing -5. So this would be -5 plus 4, -5 minus 3. So I'm going to get a negative number times another negative number, which is positive. Then you want to test in between -4 and 3, so 0 is always a good option. Be 0 plus 4, 0 minus 3, so that is a positive number times a negative number. That's a negative number. And then greater than 3, so 4. So 4 plus 4 times 4 minus 3 is a positive number times a positive number, so that is another positive number. All right, so it's asking where it's positive. So I have two places, my yellow spot and my orange spot. All right, that equals to on your inequality means these are closed dots. So my inequality, my answers have to be the intervals from -infinity to -4 with a bracket. Union. And then bracket 3 off to infinity. Okay, so on example 3, Lindsay, were these the notes that you guys had to do on your own? In your 1513 Blackboard or in the 512 Blackboard? Okay, let me look at this one. That's not a video I did. That is, that's one that gets loaded in there. Hold on, let me find it. Notes and assignments. Unit 3. There we are. Okay, let's see your question one more time. 3.4 notes, example 3. Okay. Nope, I don't want to go that. Oh, there it is. Okay. Sorry, I'm looking. So example 3. Oh, I see. Okay. Boy, I don't know that why they wouldn't have. No, that should be a turning point because it switches from increasing to decreasing there. So that should be a turning point. Okay, let me share this screen. Let me stop sharing this one. And share that one. All right, so this is the example that she's talking about. Right here. If I can get it to zoom in, we'll be doing great. Right here, I think you're talking about this point right here. That would be a turning point because it's a minimum. But it would be 2, 0, not 0, 2. All right. I have to get running here in a second. Are there any other questions?
I know on the notes for sorry,
You're good.
for 3.6, she does erase a lot of like she goes back and forth from she'll write a couple of the notes and then she'll erase it, but it's for the same question. Do you want us to write everything she writes down?
No. Write what you
No?
need. Write what you need.
Okay. Okay.
That's my friend Jill Taylor. She does those notes, and so she writes things down, um, just kind of like a side note, almost sort of thing. So it's not necessarily something you have to write down every time. Okay, so like I said, I added in those rational inequalities and those polynomial inequality videos on your in your support materials on the 512. They're old notes. I don't even think I have hard copies of those notes anymore, but they're there if you want to just reinforce the inequalities. If you have like specific questions, send me an email. My high school students are testing tomorrow, so I have some time to just like sit and help as I need to. And I don't have a chock full weekend, so I can help a little bit more there too. But definitely keep an eye on those deadlines because they are coming up. For those of you that came in later, I am allowing for test corrections on the midterm. Um, so I will be emailing all of you a PDF of your midterm. You can do test corrections on the one you missed for half credit back, and that deadline is November 21. And I'll send an email out to everybody as well. So that should help a lot of you guys. I made a note to double check final, make sure it's open, the final exam review that's open earlier and that you can do it more than once. Any other questions for me?
The reviews for 3 and 4, can those be that we can do them more than once as well?
I think so, but I'll double check on that one too. I know that you can always go back and practice. At least that's been my experience in Lumen, but I only see it from the teacher side, so I don't know what it looks like from the student side. Um, oh, I guess I do just student app. Okay, who knew? Let's see. What I'm seeing is that you haven't. What I'm seeing on the student side is that it says something like the assessment is in practice mode. And so I would imagine that means you can get into it and just practice on it. I don't know. You can't submit it, but it's there for you to practice on. Um, so try that and see what happens with it. It just won't submit your work. Does that make sense? Like it won't go in as a score. That's the impression I'm getting. Okay, any other questions? All right, guys. I'm gonna let you go. Please, 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 because as we're getting closer and closer to this final exam, I know that's going to be more and more and more pressure on you. When you get stuck on a question, if I don't answer right away, send it again. Because I've been discovering my Lumen questions are going to my junk mail instead of my actual email. So try sending in Blackboard or an actual email through TCC, because the Lumens, I'm not always seeing those right away. Okay. Um, I think that's everything. Everybody okay? Awesome. November 21 is the deadline for midterm test corrections. I'll get these sent out tomorrow. And we're good to go. Y'all have a good night.